Hi there guys, got a video here for you today on the AGT Vulcan 3, and in this video we're going to be tuning the rifle. Now, rifle tuning means a lot of different things to a lot of different people, but to me personally, tuning the rifle means improving it over the factory offering. So this could be in any number of ways, improving the shot count, making the rifle cycle nicer, anything like that. And in this video we're going to be covering three main areas. So the first thing I want to do is improve the feel of the cocking. Now, to be fair to the rifle is nice and slick out the box. However, the spring ball detent that holds the pellet probe back is a little strong in my opinion. So if we open the arm, pull it back to about there, we come up against sort of a firmish wall, then we have to pull through that in order to cock the rifle. Now, that feels a little excessive from the factory, so we're going to be making that a little lighter. The next area that we're going to be trying to improve on is the action noise when you fire the rifle. So obviously, this being a bullpup rifle, your head is right here above the action, and when you fire the rifle there is a bit of rattling coming from the back. What I'm going to be doing is making some PTFE spring guides for the hammer spring, as well as making a new hammer with a Delrin tip on it. What this should do is quieten the impact of the hammer hitting the valve. At the moment, obviously, you have a steel hammer hitting a steel valve pin, and when those two come together, they make a little bit of a clang. The Delrin tip in the hammer should alleviate that problem, as we'll no longer be having a metal-to-metal contact, it'll be metal against plastic. And then finally, I would like to improve the efficiency of the rifle. Now, to be fair to it, this rifle is nice and efficient out the box. From a 200 bar fill, we was getting around 300 shots. And when you consider that this particular rifle is a 300 bar fill, if you filled it up all the way to 300, you'd be getting close to 600 from the factory rifle. Now, that's already plenty of shots, but I think we can make that just a little bit better. My ideal goal for this rifle would be to get 1,000 shots from a full fill. So I'm really hoping we can accomplish that goal. With that all said, that's pretty much the project introduced. What I'm going to do now is strip the rifle down and bring you back when we start modifying components. Right then, so I've gone ahead and disassembled the rifle down to this piece here. Now, if you need a full disassembly guide on the AGT Vulcan 3, we do have a video on the channel showing both the assembly and the disassembly of the rifle. But I didn't want to cover that again in this particular video, so in this one we're just going to be concentrating on the tuning. But with the rear action disconnected from the rifle, you can see the detent. So if we pull the pellet probe back, see it's a fairly stiff detent. Then to actually get it out of the detent, you do have to pull it pretty hard. Now, when it's all assembled in the rifle, you do have the mechanical advantage of the lever, but I would like that to be a little lighter. So I'll take the probe out and I'll show you what I'm going to do. Right then, so we've got the pellet probe chucked up in the 3-jaw, and we're just going to be taking some light passes over this face here. Right then, there's about 0.1 millimeters taken off the OD. What I'm going to do is throw this back in the action and see if there's any difference. Right then, so this will be pass number 3. It's getting better every time, so one more should do the trick. Right then, so that should be good on the OD. I did also come through there with the 45 tool and a file just to clean up the edge. Right then, and here we are back from the lathe. So as you can see, the pellet probe here has had a good polish. I have tested it in the rifle just to make sure everything works, so there are a couple of scuffs here and there. But what I ended up doing was taking about 0.5 millimeter off this diameter here. What I also went ahead and done is put a little lead angle on this front edge here, just so the pellet probe engages nice and smoothly with the detent. Right then, and with that all done and back in the action, I have to say that the detent feels nice and smooth. So it's got a nice positive lock in the back there, so the pellet probe isn't going to fall forward of its own accord, but pulling back it's lovely and smooth to get it in the detent. So that's going to feel fantastic on the rifle. There's a couple other ways you could achieve the same result. One, you could bend this spring plate slightly up, and that would loosen the spring tension on the ball bearing and therefore make the detent lighter. Or if you didn't want to bend the spring plate, you could also put a small amount of packing under this screw between the spring plate and the block. But with that all done, that's modification number 1 complete. We can now move on to the hammer spring and the guides. As I said before, on the hammer, what we're going to be doing is remaking it with a Delrin tip in the end. We're also going to be making some PTFE spring guides, so what we'll do now is just take you over to the lathe and show you us making that. Right then, and here we are all set up over at the lathe. I've got a piece of stainless steel chucked up in the 3-jaw, and we're just comparing the old hammer against the new material to make sure we've got enough stick out. Now the job itself is fairly simple, so I'm not going to go through blow by blow explaining what I'm doing. However, there are a number of things that I would like to cover. Firstly, the material choice. So in my little workshop, I don't currently have the facilities available to harden materials properly. So this particular hammer will be left unhardened, and that's one of the reasons I have chosen stainless steel for this job. The grade of stainless that we're using here is 304. So it's a free turning stainless, although it does hold up very well to wear. Along with this, the sear shape of the AGT Vulcan 3 is fairly favourable for this material as well. The sear shape isn't like a knife edge, and it doesn't rely on two perfectly flat faces sliding across one another. The sear shape is angled, and as long as the two angles match, the hammer should work perfectly well. I have made quite a few hammers out of this material, and I've never had a major issue with the material choice. Although to be fair, these are sub 12 pound rifles, so the hammer spring tension is nowhere near as high as it would be on an FAC rifle. Whatever the case, that's the reason for the material choice. With that said, we're moving through quite nicely. The next thing we have to do is press the Delrin pip into the end of the hammer. The Delrin pip was just something I made very quickly off camera. The OD is around 4.1mm, and the hole we've drilled in the end of the hammer is around 3.9. I normally just press these in. I don't normally bother with any sort of glue. Both PTFE and Delrin are very resistant to gluing, and in my experience the glue has been more of a hindrance than a help in the past. So I choose just to press the two pieces together. When the Delrin's in use, it's always going to be compressed back into its seat, and it should be pretty obvious to the shooter if it ever comes out. Although I've never had a pip come out, and again I have made quite a few hammers now. With that said, the next thing I want to talk about is the material choice for the tip of the hammer. So there are a couple available. We have PEEK, Delrin, or just plain metal. For sub 12 pound rifles, Delrin works exceptionally well, although for FAC rifles Delrin can be a little soft. PEEK, which is another plastic, is the better choice for FAC rifles as it's much harder, although it doesn't have the same sound insulation properties as Delrin. It's much harder, therefore you do still get a bit of a smack when the hammer hits the valve. I will say though, it is better than metal on metal contact. The next thing we have to do is get the PTFE installed on the rear of the hammer, and again the PTFE guide was just made very quickly off camera. It was simply a piece of PTFE turned down to 12mm with a 5.5mm hole drilled through the middle. With a 5.7mm spigot turned onto the end of the hammer, the PTFE can be pressed into position and then turned down to our correct dimensions. We're copying pretty much exactly the original hammer, although obviously with the addition of the new features. Again, I don't bother gluing the PTFE as glue doesn't stick to PTFE whatsoever. But our press fit is fairly tight, so I'm confident that the PTFE will stay in position. There's a few reasons why we're using a PTFE guide. Firstly, it insulates the metal hammer from the metal spring. This helps to reduce the amount of ringing that you get between these two components. Secondly, PTFE is extremely slippery, and it provides a good surface for the spring to rub against, as the spring will move and rotate when the rifle is in use, and the PTFE just allows it to do what it needs to do. The spring is not a tight fit over the PTFE, it needs to be a nice close fit, although the spring does need a little bit of play on the actual PTFE guide itself. If it's tight, you can get inconsistencies, and if it's too loose, the actual PTFE guide doesn't really do much. Springs are very rarely a consistent inside diameter, so what I tend to do is turn the guide a little big, then come through with the spring and just test fit it on the guide. Once I find a nice slide-in fit, I give the guide a tiny bit of clearance, then I call it done. The last thing for me to do was to put the angle on the front of the hammer, and this angle interacts with the trigger sear. And all I did was match the angle on my 45-degree chamfer tool to the original hammer, and then turn that onto the end of the new hammer. But with that all said and done, that's pretty much it. There's the hammer completed. What we'll do now is take you over to the bench and I'll test it. Right then, so that's the new hammer made. As you can see there, we have our PTFE spring guide at the back, which slides nicely through our spring, and we also have the Delrin tip on this end. So I'm hoping that's going to reduce some of the action noise down. I will try and get you a comparison between the original one and our new one when we put the rifle back together. But before we get into that, there are just a couple things I would like to point out. Firstly, we already had a PTFE spring guide in this end of the rifle, so we made that some time ago. And I have also given the spring a good polish up. So as you can see there, both of the ends have been polished and the outside diameter has been polished as well. Polishing the ends of the springs just help the spring run more consistently in the rifle. The other big benefit of polishing the ends of the springs is that when you use your hammer spring adjuster, it takes less time for the hammer spring to resettle after the adjustment. So typically speaking, when you adjust your hammer spring using a rough edge spring, it takes 5 or 6 shots for the rifle to settle back down again. Polishing the ends of the springs speeds up this process quite dramatically, and overall just makes the whole thing work just a tiny bit better. All of these improvements here aren't revolutionary, but when you add all the small pieces up together, you get a nicer package overall. So the other things we've done is just polish up this little nub here. This little nub runs across the back edge of this piece here, and this has also been given a little polish. The only thing I haven't given a polish is the trigger sears. Now this unit here is a fixed unit. As you can see there, the pins have been banged in and then pinned over to retain them in position, and I haven't polished those because I don't want to run the risk of getting any polishing debris within the trigger cassette itself. With that all said and done, that's pretty much all of the modifications done to these pieces there. The next thing we're going to talk about is the efficiency of the rifle. Right then, the next thing I want to talk about is the efficiency of the rifle. We're going to be improving this in 2 ways. Firstly, by adjusting the regulator to its most efficient point, and secondly, by using a transfer bolt sleeve, which is this piece here. This piece screws inside of the block and blocks some of the transfer bolt off. So I'll briefly go over the method, why it helps, and the results from these 2 adjustments. So the first adjustment is the regulator. What we've gone ahead and done is set the regulator to its most efficient point. I've done this by adjusting the regulator up to around 160 bar. I then filled the rifle to 160 and shot it down. What this effectively does is remove the regulator from the rifle and allow us to find the point at which the regulator was most efficient. Now that all sounds way more complicated than it actually is. All you have to do, set the regulator high, shoot the rifle down. As you shoot the rifle, shoot it over the chronograph and record your feet per second readings, as well as a record of the pressure setting. So for example, when you shoot the rifle down to 140 bar, record the feet per second and the respective pressure. If you map those results out on a map, you'll get a bell curve. So imagine you had feet per second on the side, pressure along the bottom. The point at which the graph was the highest would be your desired reg pressure setting for the most efficient rifle. In our case, the factory did a pretty good job. On this particular rifle, I found the most efficient setting to be 105 bar, although I would recommend checking your rifle as they may be slightly different. I don't want to go over too much detail in this video if I'm honest, as I think this topic deserves a separate video. What I'm probably going to end up doing is making a separate video on finding the perfect reg pressure for your rifle. So if you're interested in that, it may be worth subscribing. But with that said, that's improvement number 1. Improvement number 2 is the transfer port sleeve. So if we have a look at the transfer port inside the block, which is this hole here, you can see it's rather large. It's 6.8mm from the factory, and that's tap-in size for M8. What I've gone ahead and done is make this little device here, which screws inside the block and reduces the size of this hole to 3mm. So I'll show you how that fits. If we use a 5mm Allen key, put that in the back, and then screw that into the block. We can then take a look inside the block, and hopefully you'll be able to see the bottom of the transfer port sleeve there, and the top of the sleeve just poking its head out there. Now both of these items here are flush or just shy of the actual block itself, so they're not protruding. They won't come into contact with either the barrel or the back end of the valve. Alright then, so why have we done that? And the answer is very, very simple. All we want to do is slow down the expansion of the air released by the valve. So if you imagine we have a store of regulated air behind the valve. As the hammer hits the valve, a small amount of this air is let loose, travels through the transfer port and pushes a pellet down the barrel. Now the transfer port's job is to get air from the valve to the barrel, and the actual size of this hole dictates how much air can flow through. Now for FAC rifles, you need a nice big hole to allow as much air through as possible. Now this does have its limitations as well, which I'll go over very shortly. But for sub 12-pound rifles, you don't need that giant hole. All that hole does is take up some of the expansion of the air, and you actually lose efficiency by not allowing the expansion of the air to occur behind the back of the pellet. The easiest possible way I can explain this theory is by bringing back the valve and the barrel. Now, if we were to strike the valve in this setup, what do you think would happen? Would a pellet be pushed out the end of the barrel, or would we just hear a very loud bang? Hopefully, common sense will tell you that we will hear a very loud bang, and that's because the transfer port, in this situation, it's the actual room we're in, is just far too large to channel the air into the back of the barrel. If we bring back our transfer port, as you can see there, it channels the air from the valve into the barrel, effectively restricting the expansion of air into this hole. In other words, you want as much expansion of the air going to behind the pellet rather than before the air reaches the pellet. Now, to be honest with you, again, it all sounds much more complicated than it actually is. And all we're really trying to do is concentrate the expansion of air behind the pellet. Now, for FAC people, the actual hole size is nice and easy to work out. The hole in the sleeve should be relative to the bore of the barrel. The barrel itself acts as a natural restriction, so having a transfer port much bigger than the barrel doesn't really improve the efficiency of the rifle. It probably is wise to just oversize the transfer port hole just very slightly. So for example, a 2.2 barrel, which is 5.5mm, would probably need sort of anywhere between a 5.5mm hole to a 5.75mm hole. For sub 12 rifles, it does get a little harder to calculate, so what I normally end up doing is just making one of these with sort of a 2mm hole through it, putting the rifle over the chronograph, drilling it out to something like 3mm, and trying to find the most efficient point. In this situation, the most efficient point would be where the power peaks. But again, the easiest way to work it out is just by trial and error. With that all said, I hope that all makes some sort of sense. What we're going to do now is put the rifle back together, and I'll talk about some of the results. Right then, and that's the rifle put back together. The only thing I've left off is the little cover piece in this area here, and the last thing we'll do is just get you a shot between the original hammer and the new one. So what I'm going to do is put my microphone right next to the action, and you hopefully will be able to hear the difference. Right then, and hopefully from that you can tell the difference between the two hammers. Actually, in the shoulder, when you've got your head right up against the action, there is a tremendous difference. You still do get a little bit of smack where the hammer hits the valve, but it's much less of a metal-to-metal contact, so you don't get that sort of ting you get when you hit two pieces of metal together. It's much more of a dull thud. With that done, overall I am super happy with the changes that I've made to the rifle. The rifle is nice and slick to cock. The action noise has been greatly reduced. And overall the efficiency tuning has been a success. So, how many shots do you reckon I got out of this rifle? Bearing in mind this is an aftermarket bottle, so the maximum fill of this particular rifle here sits at 250 bar. And from my calculations, there is a 480cc bottle and then another 130cc's worth of air. So 610cc's in total. This is a sub 12 pound 177 rifle, and from a full 250 bar fill, we was able to get 853 shots out of this rifle. And I'm absolutely over the moon with that. It's a little shy of my target of 1,000. However, I still have one or two more things that I would like to do to this rifle, and if we were to swap out the aftermarket bottle for the original one, fill the rifle up to 300 bar, we would get well over 1,000 shots. From the calculations I'd done earlier, I would get around 1,100 shots, and that is obviously because of the extra 50 bar of air. With that all said, that's pretty much all of the modifications that I would like to do to this rifle at the moment. You may have noticed we did absolutely no accuracy modifications to this rifle, and that's simply because this rifle is absolutely fantastic out the box. So these are all 5-shot groups done at 50 yards using unweighed, unsalted pellets straight through the magazine. As you can see here, I don't think you could ask much better from a hunting rifle. So all of these 4 rows at the top here, 5-shot groups, 50 yards, and then when you really concentrate, pull yourself in, you can get stuff like this. So absolutely fantastic groupings. If we take our setter calipers, just measure 1 or 2 of these groups here. So that one looks to be roughly a 13mm group edge to edge. So that's a 177 pellet. That would be 8.5mm centre to centre. As you can see, this is all done in one sitting. The rifle really does shoot well. Now that we've made our small little modifications to it, it also feels really nice to shoot as well. With that all said and done, guys, that's pretty much going to do it for this particular video. Thank you very much for watching. I hope it's been useful, and we'll see you in the next one.